Welcome to Pacific Mammal Research's Marine Mammal Highlight Series. We are a 501c3 research and education nonprofit studying marine mammals in the Salish Sea off Washington State. In this series, you will learn about different marine mammals as we discuss interesting facts about each species. This is our way to geek out, share some information, and have some fun. We hope you enjoy the series, and be sure to follow us on Instagram to vote for which animal we talk about next. And without further ado, welcome to the PacMam podcast. I'm Cindy.
And I'm Kat.
And this week we're back to a marine mammal highlight. Yay! It's been, I guess, like 2 months now. So we skipped one because.
Oh, that's right. Yeah.
So we're back to that. And thank you all for voting. It was between the ringed seal and the harp seal, right? Is that what I did?
Think so.
Yeah.
I've already forgotten. I'm like, ring seal, that's what we're doing.
I know who won, yeah. So the ring seal one was like 53 to 47%. So it was pretty close, right? But the ring seal one, I think we've had the ring seal on before and it lost. So I'm kind of excited that it got to win this time.
Mm-hmm.
It's really cool animal. And actually, well, I'm sure Kat will talk about it, but I will oftentimes mention this when I'm talking about harbor seals for a specific reason, based on what it looks like and stuff. So if you don't, I'll bring it up. We are excited to get back to our Marine Mammal Highlight series. And so Kat is going to start us off with what they look like, which is super cool.
They are super cute.
Mm-hmm.
Super cute. So let's get into it. So with these guys, the clue is in the name, right? So they are named for their, I know, shocker. You did not expect to hear that from our ring seal episode, I bet. So they are known for the light colored rings on their back and sides. And so their overall body color is typically a dark gray to brown. And then they have these light colored rings that are kind of smattered all over their body. And in some seals, it actually does. I saw that in a couple places where they said that the rings are so dense that it actually does almost look like a splatter pattern because there's so many rings kind of overlapping.
So that's what happens with at least Atlantic spotted dolphins, when they get individual spots when they're younger, and then as they get older, it fuses and they become more like a splotchy pattern rather than individual spots. So that's interesting.
Yeah, I didn't see it necessarily correlated with age.
Right.
But I mean, it might be, I'm not sure. It might just be more of like individual animals have more dense patterns than some, but
yeah, and that happens with spotted dolphins too. Like I wasn't necessarily saying that this one was age, but just that there are those differences.
Yeah, no, I was just thinking like, oh, I wonder if it does. Because when they're, like other ice seals, when they're born, they start off with that white lanugo coat, right? So they shed that after about 4 to 6 weeks. And basically that's just to help them blend into the ice and reduce the risk of predation.
And keep warm before they get their blood.
And keep warm. Yep, exactly. So they do shed that at about 4 to 6 weeks and start to take on this darker pelage pattern with the light colored rings. They are the smallest and most common Arctic seal, which is very cool.
And that's why I say it in the harbor seals, because the harbor seals are the second smallest seal. And the ring seal is the only one that's smaller.
There you go. So these guys are averaging a length of about 4 to 4.5 feet. They're so small. Especially because a lot of the seals we talk about are like up to 7 feet long or like 6 to 7 feet. And I'm like, oh, these are like so cute.
And then their weight, right? Their weight is it's like under.
The weight's like 100. Yeah, I was just getting to that. Yeah. So the weight's about 110 to 150 pounds. So like a petite woman is about 110 pounds. So like they're pretty light. The average weight of a ring seal pup at birth is only about 10 pounds.
So
that's less than
other seals are quite larger.
Yeah, so that's less than a bag of flour.
That's a normal baby size birth.
Yeah, it is. It totally is. I didn't even think about that. Yeah, it is. Yeah, exactly. So they do have, in terms of additional appearance stuff, they have a pretty small head. I love this, a short cat-like snout. So I think what that means is it's kind of like the harbor seal, right? So it has a little bit more of that dish face, but it's not quite as much of an elongated nose, which kind of makes sense again for an ice seal because the longer appendages have more likelihood of freezing. So they do tend to have slightly shorter appendages. And a plump body, super cute.
That's right. I always hear, sea puppies, seals as dogs, but not related to cats. So that's interesting.
Yeah, and I think because it is a little bit wider too. Like when you see them face on, they do have a little bit more of that kind of like, it's a little bit more spread than some seals. So speaking of ice and relating to ice, they also have thick, strong claws on their foreflippers. Again, the foreflippers are a little bit shorter than some other seals, and they use these claws to help to maintain the breathing holes. And they're doing this through 6 or more feet of ice. So they have to really work hard to keep these open.
6, I mean, imagine digging with your claws through even a few inches of ice, let alone 6 feet of it. Those claws have to be gnarly.
Well, and I was curious too, because I'm like, do they keep growing over their lifetime? Or like the more you scrape away at this, do they just, I mean, I would imagine they would like be any like other animals where the claws keep growing. Because like dogs, you have to keep clipping the claws, right?
Yeah.
But
yeah, I mean, yeah.
Anyway.
So, well, that brings up another thing. So if they did keep growing and you had them in captivity, for example, and they didn't have to claw through the ice, would you have to?
You'd have to trim their claws. You would have to trim their claws, I would assume. Yeah. Good question. So in terms of distribution, we've already kind of alluded to this, but they are an Arctic species. So they're circumpolar. So they're found in all seasonally ice-covered seas in the Northern Hemisphere. So basically anywhere that is covered with sea ice, these guys are typically found. And in some freshwater lakes, which is very cool. So during spring and winter, they are found throughout the Beaufort and Chukchi seas. They occur in the Bering Sea as well, as far as Bristol Bay. Which is, you know, for those of us on the west coast of the US is probably quite familiar. That's a big fishing ground. And that's really only in years where there's extensive sea ice coverage. So they don't go down that far south typically, unless there's a lot of sea ice.
Which is probably happening less and less.
We'll get to that later. Yeah, put a pin in that, because as you can imagine, with all ice-related seals, we are going to be talking about climate change.
Yeah.
And then in the wintertime, in the Bering and Chukchi seas, they do migrate northward in spring with the receding ice edge. So basically, as things warm up, they start moving north to stay with that ice. So they're typically spending the summers in the pack ice in northern Chukchi and Beaufort seas. So yeah, they're pretty cool little guys. We'll get to a little bit more about their again, their status and their distribution in terms of the different populations and how they're doing a little bit later.
There's quite a bit of subspecies, right? Like there was like a whole different section.
There are 5. There are 5 subspecies.
Yeah, because I was I was kind of going through it and I was like, oh, okay, I'm sure Kat's going to talk about this, but whoa, there's a lot.
Yeah, so good point. Maybe I'll mention that now and then we'll circle back to it when we get to the status. So there are 5 currently recognized subspecies of ringed seal. So there's the Arctic ringed seals. So these guys are Arctic Basin and those Bering and Labrador seas. There are the, I can never say this word, Okhotsk.
Oh, the Okhotsk.
Yeah. I can never say it. So they're found in the Sea of Okhotsk.
Yeah.
The Baltic ring seals, which are found in the Baltic Sea. The Ladoga ring seals, which are found in Lake Ladoga, Russia. And the Saimaa ring seals, which are also found in Lake Saimaa in Finland.
Interesting. Okay, so yeah, the Lake Saimaa ones come up quite a bit in when I was excuse me, looking through things, but I didn't realize there was another one that had a lake association.
Yeah, so there's so those two, the Lake Ladoga in Russia and Lake Saimaa in Finland, are the two kind of lake-related subspecies that are known. And we'll circle back to that when we get to the status and stuff, and talk about how each of those subpopulations are doing and why.
Yeah, well, I'm glad you brought them up here because some of my stuff relates to different populations. Like
perfect.
Certain ones do certain things and other ones do other things.
Got it. And I didn't really see any elaboration on it, but quite a few places did say that there are some phenotypic differences between the different subspecies. So again, I couldn't really find any information about what that looked like, but I would imagine with something like spotting patterns or ring patterns, I keep saying spotting patterns because we do harbor seals, but ring patterns. And like slight coloration differences too, I would assume would be what they're talking about there. But
it would be really interesting too, if you're talking about the individual variation. You know, we see that with harbor seals, right? There was one actually, Sierra got a picture of it the other day, and it has like almost no spots. I mean, it's just
we've seen a few like that where they're almost non-spotted. It's very strange.
And then you have them all the way through very pinpointy spots, like all the way through to just mottled coloration pattern, like such a huge variation. And I think if we looked, I think there has been some with harbor seals where they showed geographic coloration differences in different locations. So I wonder if there is, you know, like maybe the Saimaa seals are all like mottled and the other ones are more pinpointy spots or not, or there's just individual variation within each population. But it'd be very interesting to look at because a lot of times you can find geographic reasons or correlations. with what they look like.
Yeah. Yeah. So that's what I have for their appearance and distribution. And so, like I said, we'll circle back to a few of those things later on.
Yeah.
But for now,
Diet
let's get into it.
Their diet, I mean, so here's the thing. These guys are in the Arctic.
Let's preface
this. So there's not a ton that we know about them in besides generalities. I mean, there has been work on it more recently, but I don't think they've been real topic of conversation overall. So we do know stuff, but there wasn't a lot of details, right? It's just like, well, So their diet is they eat a wide variety of mostly small prey. There was no reference as to what small means, but they're only like 110 pounds, so it's probably eating
right, 4.5 feet. They're probably going to not be able. And as we've talked about before, seals do typically swallow their prey whole. Right. They can sometimes kind of smack it around and break it up a little bit, but for the most part, they are sort of slurping these things down whole. So you can imagine they're probably not going to be going for like a 3 or 4 foot fish if they're like 4.5 feet.
I can do it.
That might not end well for anybody.
No, I mean, maybe somebody did try it and that probably didn't work out well for them. But what's interesting is that so the prey is mainly fish, but also crustaceans, and I think I saw also amphipods. Like it's very kind of seal like harbor seal like, where it's pretty general. So what's interesting is that they have this wide variety, but there are no more than 10 to 15 species in any one geographic location that tend to be what they eat. So they eat 10
to 15 species of fish or arthropods, right, or whatever.
Yeah.
Okay.
So overall, if you added up all of the ring seal populations, they eat, say 50 different things, right? But in each location, it's really only 10 to 15.
Which is what they found with the commoner harbor seals in the UK as well. When they've done diet studies around the UK, they find that they're generalist predators, but in each location, they sort of specialize in 1 or 2 things because that's what's really prevalent in that location. Yeah,
it makes sense because they're going to opportunistic predators basically change what they eat depending on what's available since they can.
Yeah, that's cool.
And then of those 10 to 15, only 2 to 4 of them are considered really important prey. So they eat 10 to 15 things, but really focus on 2 to 4, which again makes sense. Those are probably the most abundant things. They eat those mostly, but then they'll snack on other things.
Yeah, makes sense.
Yeah. So fishes in the cod family tend to dominate in many locations through late autumn and through spring. So again, the prey that they're eating is going to probably change seasonally based on what's happening with the fish life cycle and crustaceans and whatnot. So cod, but apparently cod is fairly important overall. And what's interesting is that crustaceans appear important in many areas during the open water season. So there are times that they are basically associated with the land fast ice, breeding and molting and things like that, and which we'll get to. But then there's other times where they're basically out in more open water where the ice breaks up, right? So during those times, apparently crustaceans are important. And also particularly important for juvenile seals. So I'm not sure why. Maybe they can't dive as well. But then that wouldn't, I mean, I guess it depends on the topography. Like if the crustaceans or whatever that they're eating are in shallower waters and they can't dive as well, then that would be good. But I don't know.
Right. And I mean, you might get to this later, but I know for some other seal species, we've talked about that they kind of segregate based on age class. Do these guys do that? Do we know? Or
I didn't see anything on that. So I don't.
Okay. Because I'm just wondering, maybe if the juveniles are all hanging out in one area and that's where they're, like you said, maybe shallower spots where there's more likely to be crustaceans present.
Right. Yeah, that could very well be. And I'm going to put a pin in that too, because we'll reference back to it when we talk about the new study stuff that they've been doing about food in the juveniles. So, but yeah, you're right. There is oftentimes age segregation in what they're eating. So it kind of makes sense. Or maybe the crustaceans give them something else that they need in those high metabolic times of being a juvenile. Or they're just fun to crunch.
Right. I was going to say, maybe they're just like teenagers where they're like, I just want chips all the time. Like they're just crunchy little sea snacks.
Exactly. So they can dive to depths of 150 feet plus. The record I saw, or the highest one I saw, was 300 feet and for 45 minutes. So they're pretty good. Yeah, holding them, which makes
For
sense.
such a small species, though, that's actually quite surprising.
Yeah, usually the smaller you are, the less breath capacity you have. But they must have evolved to that too, because again, they have to claw through 6 feet of ice, so you better be able to hold your breath long enough to open one of those back up.
You make a good point. Yeah, there is that
necessity, right? Okay, so for behavior, again, you kind of already touched on this. They have those north-south or inshore, offshore migrations with the seasonal ice. In the winter and early spring, they will carve out layers in the snowdrifts. This is super fun about the reproduction. It's really neat. And they have these layers that they carve out in the snowdrifts over their breathing holes. So they have these breathing holes, and then they will carve out with their claws a little layer to sleep in and molt and breed and whatever and give birth. So it's super, super cool. They will change from, let's see, and as the spring comes about in mid-May to mid-July, it warms up and the snow melts over their breathing holes. So there goes their layer, unfortunately. So they'll change from using their layer to basking on the surface at or near the breathing holes, near the layers or cracks. And this is when they're undergoing their annual molt. So we've talked about that before in seals. All of them will lose their hair. Some of, sea lions tend to do it throughout the year. Others, true seals, tend to molt at one particular time. And so this is their annual time. They lose their hair. It's, I think I wrote it down. I think it was like 3 to 6 weeks. And an important time because, as with many other seals that we've talked about, when they're molting, they don't eat or eat very little. So they have to be able to withstand that and basically lose weight during the molting process. They are usually found alone. They are kind of solitary loners, but they can be in large groups during the molting season, gathered around cracks or breathing holes in the ice. So again, all the snow is melting, so it's a bit more open. It's like having an open floor plan instead of individual rooms in your house. Everybody just kind of sees each other. So that's kind of what I had for behavior. So again, we don't know, we know that they move around, and I don't know really if they do much more than just migrate with the food.
Well, and it makes sense if they're more solitary too. It kind of makes sense that it would be harder to study behavior because you're tracking an individual versus you're observing a whole group of animals together.
Right. And they're spread, the populations are spread over large areas. So it's like, well, okay, what are the group as a whole doing versus any individual or whatever? So yeah, be more difficult. So for reproduction, this was interesting. Referencing back to the different populations, the sexual maturity varies with population status, and I couldn't find anything as to what that meant. But I don't know if that means that some were really hard hit with being hunted or something like that and then made them go faster, but they can either be as young as 3 for both sexes or up to 7 sexual maturity at 7 for males and 9 for females. So it's pretty large range.
That's like triple. So if that's 3 for one and then 9, that's triple the age.
Yeah
Wow.
And they, they're living 20 to 30 years. I think you probably get to that, but it's
25 to 30.
Normal pinniped lifespan. So it's not like they're only living 10 years. So it's like, you got to get started at 3, like harbor porpoises. So I'm not sure. I wish I could have found out more of what that population status meant, but I wasn't able to.
Yeah. Do we know which direction that is? Like they start reproducing younger if they're more threatened, or okay, I'm not sure.
I would. That's what I would assume, but because if one population in particular was hit really hard with that, and so they basically had to start having babies early, or it pushed towards that. I don't know. Huh. Yeah.
How intriguing.
Yeah. So, and I couldn't see it. I didn't see it like blipped out for each population as to what the sexual maturity was for all of them. This is more general thing. So something interesting to look into. I mean, maybe if I spent like another few hours doing it, I could have found something, but I didn't have that kind of time. So what's really interesting is so that they breed annually, and the timing varies with location. So again, that makes sense with depending on what latitude you're at and what's going on in your neck of the woods. something really fun, which I did not know, is that during the breeding season, the males, their faces turn black.
Really?
It gets better. So they turn black and they have a strong gasoline smell from the scent glands. Yeah.
What?
Yeah. So much so that polar bears won't eat them and people won't hunt them because they don't taste good. Like, like males are basically won't get hunted, won't get eaten during mating season because they smell so bad.
They're like, yo, we're on a mission. Do not mess with
Right?
us for a good like month or so.
Exactly. So
That's so cool.
really interesting. Yeah. I was like, so they call them, so some of the like hunters call them like gasoline. Was it, they said, oh, I didn't write it down. They call them like gasoline seals.
Wow.
Yeah.
That's cool.
Yeah. I thought that was really interesting. So they will mate while they're nursing, which it goes for about 2 months. They will, the moms will nurse. And the mating is thought to occur under the water near their breathing holes in their birth layers. So they give birth and they hop down below and get pregnant again. And they mate about a month after birth, and then of course they have delayed implantation, just like all other pinnipeds. So the gestation lasts for 11 months with that delayed implantation. So this is where we get into the population again. All the subspecies except for the autosc have a single pup that are hidden from view within the snow-covered layers. And this is a fun word. This is your word for the day. Subnivean. It means under the snow covered.
Say it again.
Subnivean.
Subnivean. Okay.
Yeah, Niben.
Cool.
So sub under Nivean must mean snow.
Cool.
Yeah. So so those ones use the layers, and this kind of birth layering thing is unique. Like that's not a normal. I've never heard of it before in any other Arctic seals. I feel
like I have, but maybe I was thinking of the ringed seal because I've definitely heard of them using layers before. But yeah, I might have been even thinking of the ringed seal when I was thinking of that.
Yeah. I mean, regardless, there's not that many others if there are any.
Yeah.
Yeah. So the autosc seals can use the layer, and they have been known to do so. However, they normally depend on the protective sheltering of ice hummocks, HUMMOCKS, which are rounded hills of ice. So
so they're kind of using more of the natural landscape that occurs in their location. Okay.
Rather than carving out their own. Yeah, exactly.
Yeah, why not?
So again, population differences. Not sure why. That's what they do. So that they nurse for up to 2 months in that stable ice, the fast ice, which always confuses me because fast to me it seems like it should be floating in the water, but fast means it's holding fast to the land. And so what's interesting is that if they're in a place where the ice is stable, they can nurse for up to 2 months, which is relatively long for an ice breeding seal because most of there's some that it's like 3 days. It's really short. Yeah. But if they're on moving ice, depending on where they are, it's as little as 3 to 6 weeks. So I would be interested to know what the fat content of those two different milks are, right? So if it's the same milk, they just don't get as much, or does the body somehow create a higher fat content to make up for the time difference that they're doing it?
Yeah, that's a really good question.
Yeah, it would be interesting to look at that. And the pups learn to dive shortly after birth. Again, similar to harbor seals, where it's predator. If you're hiding in your hole from a polar bear or something, you better be able to dive pretty quickly and try to stay safe. They are weaned before the breakup of the spring ice in general. And the moms do take foraging trips. So this is another odd thing about these guys, because generally, again, the shorter the time frame of the lactation, the seals, especially in the more northern waters, tend to just fast and they don't do foraging trips, right? These guys do take foraging trips and spend 50 to 80% of the time in the water. The moms do. So the pups are by themselves for a long time, which maybe necessitates that having a layer, right? You can't just have your pup just laying out in the open area for anybody to come grab. And there's lots of, you'll talk about them, I'm sure, the threats, but there's lots of different predators that these guys have. So I think those two things must have co-evolved, right? Being able to be in the water and take those foraging trips, have a little bit longer lactation in such a cold area because they're using that unique habitat of creating their dens or isomics.
Well, and the thing is, too, again, thinking of how small these guys are, I mean, obviously they build up reserves, but they're not like some of the larger seals where they can rely on their blubber stores for long periods because there just simply wouldn't be enough blubber on such a small animal to last,
So
you know?
it's exactly the same for the harbor porpoise, right? They've got
Yeah,
such a high metabolism,
exactly.
they're so little, they cannot physically store enough energy to last a long time. So that's a very good point.
Yeah.
So even though they're foraging, they still lose weight. So the energetic demands on the pups are more costly to moms compared to other fosid seals because of an unusually high activity level. So if they're going in the water, in that cold Arctic water, from the like soon after they're born, even still with their lanugo coat, they don't have a lot of blubber. They're going to be just bottomless pits for energy.
Yeah.
So I thought that was interesting that their pups are so costly to the mothers that even though they're foraging, they still can't make up the difference and they lose weight in the nursing process.
Yeah.
So,
No, that makes sense.
yeah. So I think that's all the cool stuff I had about reproduction and their behavior. So they're kind of a cool Arctic seal species in terms of they do a lot of the things that the snow, like ice snow seals do, but then they have their own twist to it and they do specific things like having those layers and foraging during their nursing. So kind of cool and lots of fun words we got to learn today. Fun facts. All right, so actually we may not even have any fun facts because they're all kind of embedded in what we've been talking about, but maybe we'll have some later. So we were going to take a break here, and when we come back, we'll talk about the status and threats and some cool new research that's happening. So we will get back to you in just a minute. Okay, and we are back, back for more ring seal fun. So Kat is going to talk to us about the different subspecies status populations. And what's
Yeah. So it's kind of an interesting. I found the status for these guys very intriguing. So first of all, we often talk about the IUCN Red List when we're talking about these species. So basically, that's a compendium of
that's a better word. Compendium's way better than my list.
Thank you. Since we're sticking with fun words. But basically for each species kind of indicates whether we should be concerned about their conservation status or not. So the ringed seal is actually listed as least concern because, as again, like I said, they are one of the more common Arctic seals. However, we don't actually have a firm population estimate for these guys. We think that there are probably more than one thing I saw said that we think there are likely more than 2 million worldwide.
Whoa.
However, when we get into each of the subspecies, it's not all the same picture as we've talked about with many other species. So just real quick, I do want to mention we do have an estimated population size for the Arctic stock, that first subspecies group that I talked about. So this is kind of up in the Alaska region. And we think that's a kind of just over 300,000 individuals for that specific stock. Mm-hmm. So let's go through each one real quick. So under the IUCN, they're listed as a species as least concern. Each subspecies is also, however, listed under the Endangered Species Act as either threatened or endangered, which I find really interesting given that they are seen as the species of least concern under the IUCN as a whole.
That makes no sense. I've never seen. I know. Usually those match pretty well, like least concerned, least threatened, or like they're worried about it, but not like you're fine.
Yeah.
Then, like, so
the only thing that I can think is that they might have slightly different requirements as to what it requires to be listed as threatened or endangered under the ESA. So I did just want to define this really quick before we dive into each subspecies. So under the Endangered Species Act, threatened means that they are likely to become endangered in the foreseeable future throughout all or significant portions of their region. And endangered means that they are in danger of extinction throughout all or significant portions of their range.
So is this a difference between the IUCN looking at the population-wide, like whole population having 2 million, you're like, they're fine, but each individual population is very different?
I think so.
The ESA.
Yeah, and the ESA is again, they're using I think they're using slightly different requirements as to how you come under certain thresholds.
And is so there's populations that aren't in the U.S. so the ESA has nothing to do with them. So that may all be like ours maybe not doing well, but overall in the other places those are doing better. So then the IUCN maybe has less worry about.
Well, I think all I can think is if there are fairly good numbers that we think as a whole, there's no evidence currently to suggest that the populations are massively declining. However, the Endangered Species Act, I think, that seems to be a little bit more conservative. So again, when we get into the threats and talking about climate change, this kind of makes more sense as to why these would be considered threatened. So let's get into the subspecies. So for the Arctic ring seal subspecies, like I said, that's the Arctic Basin, the Bering and Labrador Seas. They're considered threatened. So that's the stock that we think has just over 300,000 individuals. So this is, again, threatened, is likely to become endangered in the foreseeable future.
Ooh, and you're going to talk more about this, but there's a specific one that I'll talk about with climate change and future population estimates that will go right along with this in the new.
Oh, perfect.
So yeah.
Okay, we'll get there. So the Okhotsk, I can never say that, ring seal in the Sea of Okhotsk. Sorry, anyone who actually knows.
If we've said this many times, probably both of us
every time.
Now. Sorry.
Every time I can't figure out how to say it. Anyway, they're threatened as well, considered threatened under the ESA, and then the Baltic Sea ring seals are also considered threatened. So these are all subpopulations that are likely to become endangered in the foreseeable future throughout all or significant portions of their range.
Were there numbers for those two?
No.
They didn't give numbers? Okay.
No. And then the Ladoga ring seal, so Lake Ladoga in Russia and the Lake Saima in Finland seals, those are both considered endangered, which again makes a little bit more sense given that they are associated with a lake. Lakes are often more accessible to human beings as well. And so that kind of makes more sense as to that these might be, yeah, I was going to say that just that isolation factor alone would lend itself to a less good outcome potentially, especially with things like climate change. They don't really have anywhere else to go, where a lot of these other seals could spread out to somewhere else. These guys are kind of confined to that one obligate area.
Talked about that too in the new research as well. This is good.
Oh, hey, this is perfect. Okay, fantastic. So let's get into some of those threats now that we've kind of confused ourselves with their conservation status.
They're fine, they're not. I don't know.
I know. Well, and like you said, that's the problem, where when we're looking at a species overall versus taking into account each of the subspecies that contributes to that overall count, it's very misleading a lot of times.
Well, it's very similar to killer whales, right? So overall, killer whales are doing fine, but the SRKWs, southern residents up here, are not. And there are different populations that have different levels of that, and you can't necessarily, especially for such a cosmopolitan species, or so circumpolar for these guys, you can't look at the whole picture. You have to look at those individual populations.
Yeah, and it really does come back to understanding that population level and the local ecosystem. And not just assuming that, I mean, you can say the same thing about human populations too, right? The human species is booming. Right. However, some areas of the world are really struggling, right? Like we all understand that that's a reality. So it's the exact same for these guys. Okay, threats. So obviously, number one, climate. Again, as an obligate ice species, these guys are, of course, at a much higher risk of death and all of the things that go along leading up to that, both direct and indirect, as a result of ice melt from climate change. So again, like Cindy already mentioned, as we reduce ice, we're reducing space for their breeding, their molting, their pupping. You reduce the locations where those pups are going to be safe from predators. As we already heard, you're going to see changes in reproductive status and how long they're taking to reproduce successfully. So that also has a massive impact on overall population numbers as well. And again, because they really do, they very rarely come ashore. They are mostly on ice. So if there's no ice, there's really no seals. Like that's literally how bad it could get. Another one that goes along with this, which we've talked about when we've referred to other kind of ice-related species, is the offshore oil and gas exploration and development. So again, as we are reducing sea ice levels, we're increasing our ability to get up into those areas as people and exploit those areas for natural resources. So while that's going to create a lot of indirect effects through noise disturbance and encroaching on their already reducing habitat, accidental spills are actually the biggest threat from that, where if you are doing some kind of oil exploration and you have an oil slick in that area, that's going to take out a huge amount of species.
And I mean, I hate to put this out there, but is it less likely that is it likely that they will be less concerned about cleaning it up because people don't see it, right? So when it was on Florida, everybody was like, oh my God, there's oil on the beaches and it's crazy, but up there, nobody's going to see it. So who's there to make sure it gets cleaned up?
Yeah. And also, I mean, just logistically, if you're in the high Arctic, it's a lot harder to clean it up too. Yeah. So exactly. All of those things go along with it. So I think that's partly why this is such a big threat, because it would likely be harder / less of a priority to take care of it. Right. There are still subsistence harvests of Arctic ring seals occurring in some parts of their range. The harvest levels do seem to be sustainable. Not the males in breeding season. Apparently, they're just like no go. They've got to figure it out. Like, why do they all not just do that? That's super smart.
If I was a female, I'd be like, come over here, rub that on my face.
Right? Seriously. So we do know that the Alaskan Native peoples have a long history of subsistence harvest of ring seals for both food and materials. There are co-management agreements that exist between NOAA and U.S. Fish and Wildlife with Native tribes to facilitate sustainable harvests. And the U.S. specifically does not allow commercial harvests. Those are still allowed in other parts of their range. I think, like obviously parts of Russia, I think would be included within that, and I think the Sea of Okhotsk as well. But again, it seems as though these harvest levels are sustainable. Again, they're a smaller animal. So they're likely not taking them in quite as large numbers as perhaps they once did, because we know that there were significant declines in parts of their region in the past due to those harvests, but they've been a little bit more restricted and more limited in recent years, and so that's kind of evened off a little bit.
Well, and it's a great example of co-governance. I just gave a talk recently about this, about the fact that if we can work, we really have to work together. Like, you can't just be them doing one thing, one doing another thing, we're doing another thing. If we're working together and say, these are the numbers total that we can catch or we can do, and this is how we divvy out who gets what, then that is a better way forward for everybody, including the seals. Yeah. So it's great that they're doing that.
Yeah, for sure. The last kind of human-related issue is entanglement, which is apparently a specific issue in the Ladoga and Sima subspecies, which are the two endangered species. Yeah, so obviously they can get entangled in fishing gear. So that's not ideal. Right. And then obviously predation, as we talked about. So Arctic foxes, humans, and polar bears are the biggest natural threats to the ringed seals. The polar bears specifically will hunt the pups in their dens. And again, yeah. So yeah, and Arctic foxes too. You've seen them do that on probably the Frozen Planet and all those things. So, and again, like the vast majority of the polar bear kills of ring seals are occurring during that kind of pupping season. The Arctic foxes will most often scavenger the remains left by polar bears, but they will specifically hunt them in those lairs as well if they think they can get at the babies.
Yeah, and they're so small. Like you said, the foxes aren't that big, but because those babies are so small, it's the perfect size.
Right, exactly. And again, this does go back into the climate change issue. As we know, polar bear populations are really struggling as well. So if there's less ringed seals, that means less food for the polar bears who are already struggling with their food sources.
And even if they're
so that kind of cycles around.
Yeah. So, and even if they're there, that they're maybe not, they don't have as much blubber. They're not as fat. Yeah. They're not getting such food. So.
Yeah, exactly. So that's what I have for the threats. So let's hear about what's going on with these guys now.
Some new stuff. Sorry, I just keep having the picture. I think it's from Frozen Planet where you see the polar bear jumping on the tent to crush it down. It's kind of fun to watch, but also sad because they're taking the little baby. But also, if they're taking the babies too, they don't really have a lot of fat stores when they're first born. So it's kind of like being a ball of fluff, but I guess it's enough. Something. Okay, so as you can imagine, quite a bit of the stuff that's being done is related to climate change, because these are good indicator species. A lot also because there are so many, right? Or they are the most populous seal up there, that you could be able to use them as an indicator for how well the Arctic is doing. So this one by Reimer et al. In 2019 looked at demography and climate changes. And so this is the one that's very interesting. So they coupled a demographic model, so looking at, you know, all the different ages that there are and how many animals there are and that kind of stuff, to the ice and snow forecasts. And they looked back historically. So they were able to use like back data to fill this model up, and then they could look back and forwards to see what would be affected into the future, right? How changing climate and reducing sea ice would affect these animals. And so this demographic model also is from monitoring data. So there are people that are up there monitoring how many seals there are in certain locations at least. And so they're using that data to then inform these models that then we can then use back data to look forward, which is really cool. So for just a second, I had to clear my throat off mic there. So they looked at things for up to the year 2100, and this was scary. The median decline in population from looking at with modeling through the 2100 with, you know, the sea ice declining and that kind of stuff, the median decline in the population was 50 to 99%.
Wow,
Yeah,
that's terrifying.
like very bad. And so that, you know, it shows why they may be endangered and threatened, because it's such a big deal. If the ice is not there, they're just gonna be gone. They're just not gonna be able to do it. And what's interesting is they also brought subsistence into this as well, the hunting. And so they were using, I think, looking at it with being able to use the numbers from subsistence harvesting to be able to see when the declines would start to occur, right? Because you can see like, oh, we're getting less and less seals. When would that happen? And if they look at that, the changes in population structure based on that data. Oh wait, no, was that a different one? That was, oh no, this was, okay, so that's a different one. Sorry, just kidding. I'll go back to that. This one was the when they looked at this, there was increased in pups and adults, but decreased juveniles in these long-term modeling forecasts.
Interesting.
Yeah, so you have more.
I mean that the pups just aren't surviving to adulthood,
I guess, but then you're still
Okay.
you're still increasing adults. So I'm not sure how that works, but I was linking. My thought was like, oh, well, if the juveniles are eating something different, as we just talked about previously, are the things that are associated with the prey declines with what's going on in the Arctic affecting the juveniles more than the adults and the pups?
Yeah.
So they I think that is the one. They did look at it with subsistence harvesting, but now my notes are maybe incomplete. But that was interesting that they, you know, again, that's what the power of these models are, is taking data that we have and being able to look forward and see, you know, do we really need to be worried about the species or not, you know, in regards to that. So the next one I'm going to talk about is Kunnasranta et al. This is Sealed in the Lake, which I like their title. This is about the Lake Saima seals. So they did a review of these ones, the Lake Saima in Finland. There are only 400 individuals in that population.
Wow.
Very small. So what's interesting is they've been isolated since the last ice age, I think. Something like that.
That would make sense.
I wrote that down and now I can't find it either. Oh, landlocked since the last glacial period. So yeah, they're completely isolated from everywhere else. So that makes sense that they're going to have that. But what's interesting is, so they basically just did a review. So I'm not going to go over the details of that. But what they were looking at partly is that this impoverished gene pool will make climate change threat that much worse, which is what you alluded to earlier, right? So they don't have a lot of genes to have variation to be able to make up for things. So they also said that the provision of artificial nests may be a good conservation action. And this is interesting because the artificial nest I had never really heard of before, and it's in the program that we're using for harbor seal ID as artificial nests. What is that? So I guess they're like artificial reefs. I think they're making places that they would be able to nest if needed. So that was interesting. Then Kelly et al. In 2010 did a home range and fidelity to breeding sites. They had 98 ring seals in the Beaufort and Chukchi Seas from 1990 to 2006, which was quite a long time frame, using 3 forms of telemetry, looking at their time during the shore fasts, ice time, and then the time when they're in more open ocean. Generally, the females ranged larger, which I thought was interesting because usually it's males. And they had 12 seals that ranged up to 1,800 kilometers from their winter-spring home ranges in the summer. So they went far and wide. But they returned to the same small 1 to 2 kilometer site for breeding and molting. So very cool. Specific. They're not just like this region. Like, no, this particular piece of ice is where I want to be. So the restricted movement in the icebound and breeding seasons can limit their foraging activities. So again, if that certain areas are hit harder, they're going to not do well. But it was interesting. They said limit their foraging activities for most of the year. And may also minimize gene flow. Because if everybody's coming back to the same spot, that's the same genes that are coming back to those same spots. And so now you're getting the same kind of reduced gene flow. So kind of double whammy.
Compounds the problem.
Exactly. So I have 2 more. This is, I'm going to say the name wrong. Koivuniemi et al. 2016. They used photo ID. This is super cool. Yes. So they used camera traps from 2010 to 2014 because probably standing out on those ice things is not really conducive for people taking pictures. I would not want to do it. So they were able to use camera traps, and their ring patterns are lifelong, unique patterns, just like for harbor seals for their spots. They had 220,000 images. They had 164 individuals with 43% resided in successive years.
Okay.
Pretty good. They're coming back. And they were able to get both sides and the sex of the animal. So really helpful for a lot of life history stuff. Yeah. And they, again, came back to within 1.6 kilometers between years. So where they saw those seals again was in that very tiny small range. So that shows that they have very high molting site fidelity, and suggests that they have natal site fidelity too. They come back to where they're born. And that was in Lake Sima that they did that. So very cool. And then the last one, I'm going to leave it on a good note because we talked about how bad climate change is for these guys. There was one in Riget 2013, looking at perfluorochemicals in Greenland seals. And so these are the like PFOs, PFAs, bad long-term chemicals in the environment. They have increased through 2006 with a doubling of every 6 years. But the good news is that since then, there's been a rapid decrease with the clearing of the half-lives of 1 to 2 years. So for certain chemicals, they're greatly on the decline. There were some other ones. There's a lot of different chemicals that they talked about. Some of them are still there or increasing some, but it's good news that some of these persistent chemicals that we've had in the environment are finally starting to go down quite quickly, at least in this case. Yeah. So there's some hope. We've stopped chemical and the chemicals getting to them, but they still have those gene flows and the climate change that are their biggest things on top of the polar bears. So yeah. So that's all I have for the new stuff. So don't forget, we did love doing the ring seal. Thank you again for voting it in, and keep an eye out on Instagram stories and Facebook stories for the next poll, which will happen next month. Or maybe, I don't know what we're gonna do. We'll find out. Don't forget we have merch, so go to our merch store. You can go to our website and find a link to that, and you can support us through the podcast by subscribing for a small monthly fee of $5. You get ad-free episodes and special bonus mini episodes. And this month is going to be Sierra, our research assistant, is telling us how she got to where she is today. So that'll be a fun one to listen to. So those are the ways that you can help support us. We greatly appreciate your listening and sharing of our work, and we will see you next time with likely a journal review, I think. So thanks for listening. We'll see you next time. Bye.
Bye.
This This was brought to you by Pacific Mammal Research, a 501c3 nonprofit organization. To learn more about the species we discuss, check out our blog. Head to our website, www.pacmam.org, that's PACMAM.org, to check it out. Also, help us continue providing fun and educational content like this by donating today. Your help is how we can continue to do our work and share it with you. Thanks.